Hello, my name is Lubo, and in this video we are solving some mathematical problems related to the Euler number, to the E number, as I'm going to pronounce it, and the natural logarithms and their derivatives. So this video is basically showing you the E number and its derivatives and the numbers which we get when we find the derivative of a function. And the first thing I have to say about this is that there are several rules, okay, and there are two that we will see in this video. Those two are that e to the power, the Euler number to the power of x and its derivative are the same number, the e to the power of x, and the natural logarithm of x is equal to 1 over x. These are easy to remember formulas, and in today's video we're solving 5 problems. And the problem states that we have to find the first derivative of the function and what this first derivative is when we replace the x with an actual number, or p over something, or e over something. So let's begin. The first expression is such as this, where we have e to the power of 3x times x plus 1 in brackets, and we have to find the expression when we replace the x with 1/3. So the first thing we have to do is probably tell you the formula of how we find the derivative, and what we're going to do is basically say that f times g, it doesn't matter how we pronounce it, which are functions out of x, of course, and its first derivative is equal to f, the first derivative of x, times g, yes, plus f times the first derivative of g. And this is good. Now we can deep into the problem. And now we can say that this expression here is the first number we have, e to the power of 3x, this in brackets, and its first derivative times x plus 1, which is the second number, plus e to the power of 3x times the first derivative of x plus 1. And now we can say that the first derivative of e to the power of 3x is basically 3x, the derivative of 3x, which is 3, times the number itself, which is e to the power of 3x, times x plus 1, plus e to the power of 3x times the derivative of x plus 1, which is just 1, because 1 is the derivative of 1 is 0, to the x is 1, and so on. And now we can write that e to the power of 3x. We can unveil those brackets and not unveil it, but put the 3 in it. So we can write 3x plus 3 plus e to the power of 3x. And now we say that the first derivative of x is equal to e to the power of 3x times 3x plus 4, because that expression here is just simply multiplied by 1, but we don't write that down, so we write it down here, and that is 4, not 1, sorry. So now we know what is the derivative. We can of course unveil those brackets, but at this point it doesn't matter. However, we can rewrite the expression such as this: 3 times x times e to the power of 3x plus 4 times e to the power of 3x. And now, when we know what is the derivative, we can replace dx with 1/3. So what we do now is simply say f to the power of f derivative of the function, but with a in the brackets. We can write that e to the power of 3 times 1/3, which is just 1, plus 3 times 1/3 plus 4. And now we can just write that this is e. I'm going to write e times those 3's just going to delete themselves, so we have just 1 here plus 4 is equal to 5, and that is 5e. And so we know that the function, when a is 1/3, we can really just write that a is 1/3 here. We get 5e, which is good. And now we can write the second expression, which is this. The function f of x is x times linear logarithm, no, natural logarithm, sorry, of x, and we know dA. So what we are writing now is the same thing as it was in the previous question. The derivative, not that big as the last time, the derivative of f of x is just the derivative of the first thing, which is x times ln of x, the natural logarithm, plus x times the natural logarithm of x. And to be precise, you can place brackets here. However, we're not obliged to do that. And now I'm not going to write that in details, but this is going to lead us to ln of x, because the derivative of x is 1, plus the derivative of the natural logarithm is 1 over x, as we saw before, but times x, which is just x times 1 over x, and that is 1, and that is just the natural logarithm of x plus 1. And that is our first derivative. Now we can write dA in here, because we know it is square root of e, and we can simply write the natural logarithm of square root of e plus 1. We can rewrite this expression as the natural logarithm of e to the power of 1 over 2 and plus 1. And now the natural logarithm, as we know it, is just basically the logarithm with base e, and now we can just write the full version of the natural logarithm, log down in the base e to the power of 1/2 plus 1, and this here is just 1, and if that is 1, then we can just write the power here as a number, which is the value of the logarithm, which is 1/2 plus 1, which is 3 over 2 or 1.5. It doesn't matter how you write it. And basically that's all from that question. It wasn't that complicated. And now here comes the third question, which states that the function f is the Euler number to the power of sine of 3x, and we know that a is p over 3. Now what we're going to do now is basically say how we're going to write the derivative, and here the derivative is equal to e, the number e, to the power of sine times 3x, which is the same number. We don't writing that down. I mean, the derivative of that number is the same number, so we don't have to write that down. However, we have to multiply by the power of the function to the power of e, because that is the important part here. So we write never mind, I'm going to write the whole expression's derivative. So the derivative of the first number times the derivative of the second number, which is sine 3 times x, and what we are going to write from that is that the derivative of x is equal to e to the power of sine times 3x times, and here comes the tricky part, this 3 here is going to go up in front of the sign, and we're going to get 3 times cosine of 3x, because the derivative of the sinus function is the cosine function. Now when we continue with our problem down below, we see that there's nothing we can actually do more for that question. So we can just write that the derivative of x is 3, and we're going to get that 3 in front, times e to the power of sine times 3x times cosine of 3x. And now when we want to find the derivative of the function for the number a, we don't really have to write this whole function down below and calculate with p over 3, because here to the cosine we see that we have cosine of p, which is just equal to 0, and this whole number is going to be something times 0, and the first derivative for a is going to be 0 as well. And that was a tricky part here. We have to look for such opportunities to have 0 for a number. The fourth question of the problems we have states that the function of x is equal to natural logarithm of square root of x to the power of 3, and we know what the number a is. Now what we're going to do is use the formula we used before, because now we can say that the derivative of this is the derivative of this expression times the expression of the linear logarithm. And now we're writing this 3 in front, and we're going to get 3 times the natural logarithm of square root of x times 2. And this we're going to multiply it by the logarithm itself, which is 1 over square root of x times 1 over 2 square root of x. We got that from the linear function, and because we have to, when we find the derivative, we have to get the first thing, its derivative, and multiply it by the linear function itself and its derivative, not only the square root of x. And this thing is going to give us 3 times the linear logarithm of square root of x squared over 2, because we have 2, square root of x times square root of x is just x, and we're writing x down. And that is our first derivative of this expression. Now what we have to do is replace the x with e squared, and rewrite that the first derivative of a, not x, sorry, is just 3 times the linear logarithm, which is squared, to the power, not the power, but from square root of e squared, which is just 2, over 2 times e squared. That is going to lead us to 3 times linear logarithm of e and to the power of 2 over 2 e squared. Now, as we said before, the linear logarithm of e is just 1, so we write 3 times 1 to the power of 2 if you want to be precise, over 2e squared, and that is just going to give us 3 over 2 times e to the power of 2, and that is the value for a. And now we are heading to the last problem, which states this: the f of x is the linear logarithm of sinus x plus cosine x, sin x plus cosine x, and we know the a. And this problem might be not the hardest, but the most interesting of them all, maybe the most beautiful of them all. I don't know, it's your opinion. For me it's beautiful. And now we write that the derivative of x is just as we said, the derivative of this, of sine x plus cosine x, times the linear logarithm, and what we're going to get from that. I'm not going to write in detail this time. I don't know if I wrote it in detail the previous times. Write down in the comments your opinion if you want to write more things in detail, more things to skip, or a mixture of both, as I'm doing it now. And now we can simply say that it's going to be 1 over just the function in sine x plus cosine x times the linear function itself, which is going to be sine x and its derivative is going to be minus cosine, and the is going to be cosine, just cosine. So we can write cosine of x, and the cosine of the derivative of cosine x is going to be minus sine x. And that's all, I think. Yes, that must be all. And when we write that as a single fraction, is going to be cosine of x minus sine of x over sine of x, sine of x minus cosine, so plus cosine of x. And that is our first derivative. However, when we replace the p over 6, the p over 6 is going to be 30 degrees. 180 divided by 6 is 30 degrees. 30 degrees, and when we replace those trigonometric things with actual numbers, we're going to get that cosine of 30 degrees is square root of 3, I think it must be, over 2, and minus sinus x is going to be 1/2 for the numerator, and for the denominator we're going to get 1/2 plus square root of 3 over 2. In both the numerator and the denominator we are dividing by 2, so we can delete that. We don't really need that when we're both dividing by 2, the numerator and the denominator, and we simply say that square root of 3 minus 1 over square root of 3 plus 1. But that's not going to be our final answer, because we have a fraction, we have a square root in the denominator that is illegal, and we're going to proceed when we multiply by square root of 3 times minus 1. Maybe you saw the answer, but I want to write it until the end. It is important to write things until the end, because we can make a mistake right before the finish line, and that is going to be not good for us. And if we get a mistake like this, we have to cover it more over and over again until we don't make it. And from this fraction we see that x, it's not x actually, let's say, sorry, let's say as well, and that is square root of 3, that is going to be 3 minus 2 times square root of 3 plus 1. Down we have 2, 3 plus 1, 4. We can divide by 2, and that is going to be 2 minus square root of 3. And that is our final answer for now. As you saw, we solved some problems, and that's a nice step I've just made. However, I think this video was helpful, and if you want to appreciate my work, you can like this video, you can write a comment, subscribe to the channel if you haven't already, support me on Patreon if you're willing to give me financial support, and you can send me your mathematical problems in the social medias which are down below. I have an Instagram, I'm working on a TikTok account soon, and that was from the video. I hope you found it interesting and helpful, and we're seeing in the next video. Thanks for watching.